Hello guys, welcome back to my channel BK Tech. Today we are going to solve the problem flood fill algorithm. So let me explain you what is given in this problem. So we are given with the one 2D array as an input, and we are also given with the source node. So basically we are given with the row number and column number, and we are given with the new color. So basically in this what we need to do is that we need to find out that like if we are given with the starting node as 1 comma 1, so we can consider if we consider that this is a 1 base indexing, so 1 comma 1 will be the this node. So if you see, uh, this node is having a 1 as a its color. So what we need to do here is that we need to change all the nodes present with this color of the which are having a colors of source node with the color of new node, and we can move only in the four directions. So we can go like if this is a matrix, so we can go upward, or either we can go left, either we can go right, or we can go down. So in only four direction we can move, and wherever this initial color of the source node is existing, we need to change it to the new color. So for solving this problem, what we need to do is that first we can create one delta array which will be helpful when we are going to uh, move in the four direction. So let me create it that first. So it can have 1 comma 0 comma minus 1 comma 0. Why I have kept it like this, let me tell you. So if you see that from any node you can move in the four direction. So like if you are on the node 2 comma 2, uh, then you can either move to if you see up, if you go upward, then the our row will be decreasing and it will become 1 comma 2. If you go the rightward, it will become like row will be the same but the column will increase, so it will become 2 comma 3. And in the same way, if you go left, the column will decrease, and in the same way if you go downward, the row will increase. So we are keeping the delta row in this case, and in the same way I will keep the delta column. So we have created here a delta column. Now what we are going to do is that as we you can see that we need to return the output array where the colors are changed on the basis of our condition. So what I am going to do is that first I am going to copy this image array which is given as an input to us into a one answer array. So I have copied this, and I will also make one variable which will keep a note of the initial color. So for the initial color, so we got the initial color. Now we can use the DFS algorithm in graph, by which we can visit each and every node of this. So what we are going to do is that we are going to make one DFS function here. And what we need in this DFS function is first is we needed initial color. Then we need a new color. Then we need image matrix. Then we need row and column. Then we need our answer array also, because we need to update that only. Then we also need delta row and delta column. So these all things we needed in this. Then we what we are going to do is that we are going to change the color of first node which is called in the DFS function. So for that we are going to change this with new color. Then we are going to we need to know the size of the our image array also. So n equal to image dot length. This will give the number of rows. Nm equal to image 0 dot length. This will give us the columns of the, or you can say, yeah, columns of the matrix. Then we are going to put a one for loops, which will start from 0, runs 4 times because we need to move in the 4 direction. Then we are going to uh, take out the neighbor element with the help of delta row and delta column. Basically we are moving in the 4 directions, so we can need to calculate it from the delta row and delta column. So we are going to use this del row and column, and we are going to, so we are going to plus this delta row and this. Then we are going to, so we got the neighbor elements which we want. Then we need to put the condition on this, that n row should be greater than equal to 0, because we don't want that, it should go out of bound, and it should be less than n. So we are going to put the end condition in between, and in the same way we are going to check for n columns. It should be greater than equals to 0, and n columns should be less than m. Then we are going to check that this image is a matrix which we are traversing is having a initial color which from which we started or not. So we are going to check it here. And one more thing with which we are going to check is that it the color is already changed or not, means the that we have changed the answer array with the new color. Then we don't need to change that element. So we're going to check that. Should not be equals to our new color. After this, what we are going to do is that we are going to call DFS for that element. So initial color we are going to pass in this, and we are going to pass new color. Then we are going to pass image array. Then we are going to pass new row and new column. So n row and n column. Answer array del row. So now that this implementation of DFS function is completed, so now we are ready to call from the our flood fill function, from where we need to return the answer. So we are going to pass here initial color. Then we are going to pass new color. Then we are going to pass the image array. Then we are going to pass the source row and source column. And then we are going to pass answer array, and then del row, then del column. And then we are going to return the our answer array. So this should be give us a output. Then we are going to compile this and see. So it is giving us a not in a statement. So I think I need forgot to give the space somewhere. In n row. So I by mistakenly kept the semicolon here. We need and here and also. So now I can compile this and see. Yeah, now you can see that it has passed all the test cases. So now we can submit this. So you can see that it is passing all the test cases mostly. So now we have completed the solving of this flood fill algorithm. So thank you for joining. You can wait for my next video, next problem solving. Goodbye.